In our modern world, we live by a set of rigid rules. We build our infrastructure in separate, distinct boxes. The roads are paved for cars, the rails are laid for trains, and the power grid, that invisible web of energy, stays up on the poles. These systems are never supposed to touch. They are never supposed to cross. But history has a way of laughing at our rules. In January of 1998, during one of the most catastrophic natural disasters in Canadian history, the lines between these systems didn't just blur, they were completely erased. This is the true story of how a town plunged into darkness found salvation in the unlikeliest of places. It is the story of Canadian National Locomotive 3502. It's a story about a machine, yes, but more importantly, it is a case study in desperate ingenuity, engineering resilience, and the courage to ask a question that sounded absolutely crazy. What if we drove a train down Main Street? To understand why anyone would try to park a 100-ton locomotive in front of a city hall, you first have to understand the sheer violence of the Great Ice Storm of 1998. This wasn't just a winter storm, it was a siege. For days, freezing rain fell relentlessly across Quebec and Ontario, coating everything in inches of heavy, clear ice. The weight was unbearable. Massive steel transmission towers crumpled like tin foil. Power lines snapped with the sound of gunshots. The electrical backbone of the province was shattered. In the municipality of Boucherville, Quebec, the situation had escalated rapidly from an inconvenience to a life-threatening emergency. It was mid-January. The town had been blacked out for days. Outside, the world was a frozen wasteland, but the real danger was inside. Critical infrastructure, City Hall, the police headquarters, and the main community shelter was freezing. The temperature inside these buildings had dropped into the low teens, barely 50 degrees Fahrenheit. For the elderly and the young families huddling under blankets on cots, the risk wasn't just discomfort anymore. It was hypothermia. The mayor of Boucherville stood by a frosted window, staring out at a dark town. The news from the provincial utility, Hydro-Quebec, was grim. They were overwhelmed. Repairs wouldn't take hours, they would take days, maybe even weeks. The town's backup generators were dying, running on fumes, unable to handle the load. Standard protocols had failed. They needed a miracle. They needed a power plant, and they needed it now. The solution to this deadly problem lay in a fundamental misunderstanding that most people have about trains. When we see a locomotive, we see a vehicle designed to pull heavy cargo, but ask an engineer and they will tell you something different. They will tell you that a diesel-electric locomotive is at its heart a massive rolling power generator. The locomotive that would become the hero of this story was an MLW M420 carrying the road number CN3502. Here is the secret to how it works. That massive V12 diesel engine inside doesn't actually turn the wheels, not directly. Instead, the diesel engine spins a giant main alternator. This alternator is a beast, converting mechanical energy into high-voltage electricity. In normal times, that electricity is fed into traction motors on the axles to drive the wheels. But the engineers in Boucherville had a radical idea. The physics were sound. If they could disconnect the electricity from the wheels and instead route that massive current into the town's electrical panel, the locomotive would become a stationary generator. This wasn't a toy. This was a machine capable of producing 2,000 horsepower. It could generate reliable, high-capacity three-phase power. It was exactly what the freezing City Hall needed. The power was there, sitting on the tracks. They just had to figure out how to get it to the building. The physics worked, but the logistics? The logistics were a nightmare. When the mayor placed the call to the Canadian National Railways Operations Desk, the request was unprecedented. You can imagine the silence on the other end of the line. You want to borrow a train to power a building? In the corporate world, ideas like this usually die immediately. The risks were astronomical. The legal team at CN had a laundry list of reasons to say no. First was safety. Connecting a raw industrial power source to a municipal grid is dangerous. If not done perfectly, it could cause backfeed, sending deadly electricity down the line to electrocute repair crews working miles away. Then there was liability. What if the surge fried the city's wiring? What if the train derailed while moving it? And finally, property damage. Trains are not meant to drive on asphalt. A machine weighing over 200,000 pounds would destroy the road surface. It could crush sewage pipes and water mains buried underground. It was a gamble with millions of dollars and professional reputations on the line. But as the debate raged, the temperature in Boucherville kept dropping. The humanitarian reality outweighed the corporate risk. People were freezing. CN leadership took a deep breath and gave the green light. The operation was a go. The execution of the plan was a surreal spectacle, something out of a movie. On a gray, freezing day, a heavy lift crane arrived at the tracks near the center, Boucherville. A crowd of residents, bundled in thick parkas, gathered behind police tape. They watched in disbelief as CN 3502 was lifted bodily into the air. For a moment, 100 tons of Canadian steel hovered above the ground, suspended against the gray sky, before being lowered onto the freezing asphalt of the street. This was the point of no return. And here is the most incredible part. They didn't tow it. They didn't push it. They drove it. The crew engaged the throttle. The massive steel wheels began to turn. They bit into the road surface. Witnesses described the sound as a grinding groan, metal carving into pavement, a sound that signaled the breaking of every rule for the sake of survival. Municipal workers walked alongside the iron beast like handlers with a wild animal, guiding it carefully. They had to navigate around manhole covers, knowing that if a wheel hit one, the train would collapse into the sewer system. Inch by inch, grinding and growling, they drove the train right up to the municipal center and parked it like a delivery truck. Once the locomotive was positioned, the haste turned into a delicate electrical engineering operation. The crew had to bypass the traction motors. They ran heavy cables from the train's alternator deep into the bowels of the municipal building. The target output had to be precise, 375 kilowatts at 60 hertz. If the frequency was off, they could blow out the building's systems. The engineer in the cab revved the engine to a specific RPM to match the frequency. The hum of the engine grew louder. The tension was palpable. Then the switch was thrown. Inside the shelter, the emergency lights flickered, and then stabilized. The hum of the heating systems roared back to life. The coordinator, who had been watching her breath fog in the cold air for days, felt the warmth begin to return. Outside, the snow continued to fall, but inside, for the families huddled on cots, the nightmare was over. The low, rhythmic rumble of the diesel engine parked outside wasn't noise, it was the sound of safety. CN 3502 ran continuously for days. It kept the heart of Boucherville beating until the main grid was finally restored. But the story didn't end when the lights came back on. You see, using a locomotive as a stationary generator takes a heavy toll. These engines are designed to move. They rely on the wind of travel to help cool them. Running at a fixed high load while parked caused immense stress on the components. When CN 3502 was finally lifted back onto the rails, it couldn't just go back to work. It required a comprehensive inspection. The wheel flanges were damaged from the road. The traction motors and bearings had to be checked. It was a costly maintenance job, but compared to the lives protected, it was a price CN was happy to pay. The image of that train, parked on a suburban street, remains one of the most enduring symbols of the 1998 ice storm. It reminds us that our infrastructure is fragile, but it also teaches us a powerful lesson. In an era where we often feel helpless when technology fails, this event proved that solutions often hide in plain sight. It wasn't new technology that saved Boucherville. It was existing technology used in a radically new way. The little engine that could didn't just climb a hill that day. It left the tracks entirely, broke all the rules, and kept a community warm.